fun with magnets. Lesson preview. Discovery of magnet. Magnetic and non-magnetic materials. Poles of a magnet. Attraction and repulsion between magnets. Test for magnetism. The Earth's magnetism. Magnetic compass. Making a magnet. Demagnetization. Storing a magnet. Magnetic field. Some uses of magnets. A magnet is an object which attracts things made of iron, steel, nickel, and cobalt. Magnets are made of iron, steel, or other alloys of iron by the process of magnetization. Discovery of magnet. It is believed that Greeks discovered magnets some thousands of years ago. Magnus, a shepherd, used to herd his sheep in Magnesia, in Greece, in the mountains. He used to carry a stick having a piece of iron at one end to control his sheep. One day the metal tip of his stick and the nails in his shoes got stuck to a large piece of black rock and he had to pull hard to free himself from the rock. It was seen that the rock was attracting iron. The Greeks named the rock magnetite. It is made up mainly of iron oxide. It was also seen that when the stone was suspended freely, it came to rest in a particular direction, north-south. It was named lodestone, meaning leading stone, as it used to give an idea of direction to the people. Substances having the property of attracting iron are known as magnets. The name is derived from the word magnetite. Magnetite is a natural magnet. The force that a magnet exerts on iron is called magnetic force. Magnets can be made in many shapes, but the main shapes are the bar and the horseshoe. Nowadays, artificial human-made magnets having stronger properties than natural magnets are also available. Magnetic and non-magnetic materials. You will notice that things made of iron and some kinds of steel are attracted by the magnet. Items like wood, plastic, glass, and copper are not attracted. The materials which get attracted towards a magnet are called magnetic substances. Examples are iron, nickel, and cobalt. The materials which are not attracted towards a magnet are called non-magnetic substances. Examples are stainless steel, silver, copper, aluminium, gold, wood, plastic, glass, rubber, etc. Poles of a magnet. A magnet has two poles. The two ends of a magnet are called the poles. Activity. Take a sheet of white paper. Spread some iron filings on it. Now, roll a magnet in the filings and lift it up. Observe how the iron filings are distributed all over the magnet. What do you observe? You will notice that most of the iron filings cling near the ends, poles, of the magnet. There are very few iron filings near the middle. Repeat this experiment with the horseshoe magnet. Bar magnet. Poles. Horseshoe magnet. Poles. In the horseshoe magnet, you will also see a similar arrangement. This experiment shows that magnetism is strongest at the two ends of the magnet. These are called the poles of the magnet. Activity. Suspend a magnet freely with the help of a string or place a magnet on a piece of wood or cork, and float it in a basin of water. The magnet will come to rest in the north-south direction in both the cases. Shake the magnet a little, and watch again. What do you notice? Freely suspended magnet. Magnet resting on cork floating in water. It will be seen that one end of the magnet always points towards the north. This is called the north-seeking pole or simply the north pole of the magnet. The other end points towards the south, and is called the south-seeking pole or south pole of the magnet. All magnets have two poles irrespective of the shape. Usually, north, N, and south, S, poles are marked on the magnet. Have you ever thought, what would happen if a magnet was to be cut into two pieces? We will get two separate magnets each having a north pole and a south pole. We can therefore never get an isolated north pole or south pole magnet. Attraction and repulsion between magnets. Activity. Take two magnets. Suspend one of them with the help of a string. Now bring the north pole of the second magnet near the south pole of the suspended magnet. What do you observe? Now bring the south pole of the second magnet near the south pole of the suspended magnet. What do you observe? Attraction. Repulsion. Table. Magnet 1. Magnet 2. Observation. N. S. S. Attract. N. N. Repel. S. N. Attract. S. S. Repel. When similar poles of two magnets are brought close together, they repel each other, i.e. they push apart. In other words, a north pole attracts a south pole, but repels a north pole. Similarly, a south pole attracts a north pole, but repels a south pole. Unlike poles attract and like poles repel each other. Test for magnetism. Repulsion and not attraction is a definite test for magnetism. This is used to test whether a bar of metal is a magnet or not. Bring one pole of a magnet close to the ends of a metal bar, one end at a time. If one end is attracted and the other repelled, the metal bar is a magnet. If both ends are attracted, the metal bar is not a magnet. Thus, repulsion and not attraction is a certain test for magnetism. The Earth's magnetism. Why does a freely suspended magnet always comes to rest in the north-south direction? This is because the Earth itself behaves like a huge bar magnet with its magnetic poles near the geographical north and south poles. The south pole of this Earth's bar magnet is near the geographical north pole, whereas its north pole is near geographical south pole. Thus, when a magnet is suspended freely, its north pole points towards the geographical north pole, since it is attracted by the Earth's magnetic south pole. Similarly, the magnet's south pole points towards the geographical south pole, since it is attracted by the Earth's magnetic north pole. Magnetic compass. Magnets were used by ancient people for showing directions. Travelers used to find directions simply by suspending magnets from threads. Later on, a device called compass began to be used to determine directions. A compass is a flat, circular glass box with a glass cover. A magnetized pointer, free to rotate, is pivoted inside the center of the box. The box has directions marked on it such as north, south, east, west, northeast, northwest, southeast, and southwest. It is used by navigators and sailors to determine directions. The compass is kept in the place where we wish to know the directions. Making a magnet. Activity. Place an iron bar on a table. Take a strong magnet. Place one end of its poles near one edge of the bar. Move the magnet along the iron bar to the other end, without lifting the magnet. Raise the magnet, and bring it back to the starting position. Repeat the process at least 30 times. Remember to move the magnet in the same direction every time. Test the iron bar if it has become a magnet by bringing a pin near it. If not, repeat the process. In this way, you can convert an iron nail, a needle or a blade into a magnet. This method is known as the single-touch method of making magnets. The starting point of iron bar acquires the same pole as the end of the magnet from which stroking was started. Using electric current, the above-mentioned method of magnetization is now no longer in use. These days, all magnets are made with the help of electric current. Demagnetization. A magnet loses its property of magnetism, that is, it gets demagnetized, if it is hammered or if it falls from a height. Heating the magnet above a certain temperature also demagnetizes it. Activity. Magnetize a needle as done in the previous activity. Place the needle on a piece of wood. Place the wood in a basin of water. Activity. See whether the needle points in the north-south direction or not. Storing a magnet. Magnets tend to lose their properties if heated strongly, hammered, or handled roughly. They become weaker after some time if their poles are left free. This is called self-demagnetization. To keep them safe, magnets must be stored in pairs in wooden boxes, with unlike poles on the same side. The two magnets must be separated by a piece of wood. Pieces of iron called keepers are placed across both ends. A horseshoe magnet needs keeper at one end only. Magnets should be kept at a distance from objects with magnetic components like computer, television, audio tape, mobile phones, CDs, etc. Magnetic field. We have observed that magnetic force acts from a distance. Naturally, some influence of the magnet must be active through space. This influence decreases as we go further away from the magnet. To verify this concept, place a compass needle near a magnet. The needle gets deflected due to the effect of the magnet. When you move this needle above, below, or to the side of the magnet, the needle gets deflected all around the magnet. Now take the needle farther away. The influence of the magnet becomes weaker and weaker, until at some distance away, it is felt no more. Hence, there exists a certain region around the magnet where its magnetic influence can be felt. This region is called the magnetic field of the magnet. Some uses of magnets. Magnets have a number of uses. Some of them are: magnets are used to pick iron pieces from waste. Magnets are used in magnetic stickers. They are used in closing mechanism of refrigerator doors. They are used in audio and videotapes and computer hard disks to store information. In credit cards, ATM cards and Metro Smart cards, the information is stored in a magnetic strip. In some pencil boxes, the lid fits tightly when we close it even without a locking arrangement because such pencil boxes have magnets fitted inside them. Magnets are also used in a number of electronic goods such as speakers, microphones, etc., and electric motors.